Welcome! You will now learn how to use configuration software and create a strategy for managing your AMIs. You can simplify many common administrative tasks with a configuration server, such as AWS OpsWorks with Chef or Puppet. The most common example is provisioning and deleting user access to EC2 instances. For example, say you give access to a fleet of EC2 instances to a consultant. You give the consultant a private key to log in with your user ID and perform administrative tasks on these instances. What happens if the consultant leaves the company? Without a configuration server, deprovisioning access to these machines can be a manual and complicated process. However, using a configuration server, a system administrator can use a few simple commands to easily change access to the system. They can also apply this change to all instances in the fleet. One advantage of using a configuration server is that resource creation and configuration happens once and only once. If manual modifications are made to the configuration of an instance, the configuration server detects those changes and rolls them back. This helps ensure that the integrity of the instance isn't compromised by accident. It's common for organizations to need a pre-installed base set of software on all EC2 instances. This software might include utilities developed by the organization, in-house tools for using AWS services, and advanced software for enterprise-scale activities such as monitoring and intrusion detection. You can satisfy this requirement by creating a custom AMI as a base configuration. First, you launch an EC2 instance from a standard prefabricated AMI and pre-configure all the software that your organization needs for that instance. You then create a custom AMI from it. The new custom AMI now becomes the AMI that will be used to create all new instances in the organization. As a way to maintain consistency, you can create a process that scans the running EC2 instances. The process enforces a policy that all new instances are launched only from the new base AMI. It will terminate any instances that are not using the standard AMIs. Another option is to configure instances at boot time. For example, you can use the user data option to run a script when you launch an EC2 instance. Discovering the ideal approach to AMI management means that you must consider the trade-offs between simplicity and flexibility. A fully baked AMI boots faster but takes longer to produce and build. A plain AMI that uses user data will take a long time to boot due to the installs that take place during launch. The more complex an AMI is, the greater the risk that your application will be vulnerable to a security issue. Security updates to all items in the AMI will need to be applied on a regular basis. The goal is to find the right combination of trade-offs for your organization. For more information, search for AWS AMI Design in the AWS documentation. You can create an AMI with the AWS Management Console, the AWS CLI, or with the AWS API. The resulting AMI exists only in the region in which it was created. For example, if you create an AMI from an EC2 instance that runs in the EU West 2 region, the resulting AMI will exist in the EU West 2 region. You can't then launch a new instance from the AMI in a different region. You have to copy the AMI to the region before you can use it. By default, when you create an AMI from an instance, the instance will be rebooted to ensure consistency. You can override this default behavior. However, if you choose this option, the integrity of the file system of the created image cannot be guaranteed. Also, if you create an AMI from an EC2 instance that has additional volumes attached to it, the attached volumes are captured as part of the process of creating the AMI. The command line call shown here demonstrates how to create an AMI. When you use the create image command, you must specify the instance ID and also specify a name for the AMI that will be created. You can copy an AMI to a different region by using the AWS Management Console, AWS CLI, or the Amazon EC2 API. In this AWS CLI example, the source image ID and source region are both specified. Also, the region parameter identifies the region where the AMI will be copied to. The command also specifies the name to assign to the AMI that will be created. The storage type of the AMI does not matter to the copy image command. You can copy AMIs backed by Amazon Elastic Block Store and AMIs backed by instance stores. For more information, search for Copying AMIs in the AWS documentation. When you create an AMI, Amazon EC2 creates snapshots of your instance's root volume and any other EBS volumes attached to your instance. You're charged for the snapshots until you deregister the AMI and delete the snapshots. You can also create Linux AMIs directly from the EC2 instance root volume snapshot by running the AWS EC2 register image CLI command. This is the type of process you'll want to investigate by using the documentation. EC2 Launch v2 is available by download, by installation from SSM Distributor, and on all supported Windows AMIs. It runs as a Windows service on the instance. EC2 Launch v2 performs tasks during instance startup and runs if an instance is stopped and later started, or if it is restarted. It can also perform tasks on demand. Some of these tasks are automatically enabled, while others must be enabled manually. You can change the default settings using the EC2 Launch v2 settings dialog box, which can be launched from the Windows Start menu. You can also configure it using the EC2 Launch CLI command. Among other tasks, the EC2 Launch v2 service runs Microsoft sysprep. Sysprep removes system-specific information. When EC2 Launch v2 calls sysprep, it uses program data to determine which operations to perform. The EC2 Launch v2 service supports all EC2 config and EC2 Launch version 1 features. EC2 Launch v2 uses a configuration file to control its operation. You can update the configuration file using either a graphical tool or by directly editing using a YAML editor or a text editor. Here are the three sysprep phases. First, the tool removes image-specific information and configurations. For example, sysprep removes the security identifier. After this phase completes, the operating system is ready to create an image. In the specialize phase, Plug and Play scans the computer and installs drivers for any detected devices. The tool generates OS requirements like the computer name and SID. You can also run commands in this phase. In the final phase, the system runs an abbreviated version of Windows Setup. It asks the user to enter information such as system language and time zone and a registered organization. When you run sysprep with EC2 config, the answer file automates this phase. Thanks for watching. See you in the next video.